Welcome to the GOCO instructional video series. In this video you will learn about the filter selection section in the GOCO scenario options section for a new or existing scenario, and we'll be focusing on the subsection of filter selection. On the Select Filter drop-down menu you will see in a few moments time that there are three different options to choose from. There is the bag, cartridge and pleated bag filter option. For the present case, we'll be using the pleated bag filter option, as this is the purpose of this instructional video. If you haven't done so already, please start your version of the GOCO program. Once you're at the home window or landing screen, then navigate to the top bar menu and we'll select a new scenario with which to demonstrate the pleated bag filter option. You may select an existing scenario, but it will be easier just to start afresh with a new scenario. So we click on New Scenario, and then we see the layout for a scenario. We'll be looking, as mentioned, at the Scenario Options section. Now, for the purpose of completeness, let's choose a solve mode, even though we won't be solving this case. We'll select Calculate Outlet and/or Header Sizes, GOCO 7.2 equivalent. There is no need to change the CVF or the percentage pressure remaining in the header. Now, before the filter selection section appears, we must fill in the sections before that. The first section to fill in is the valve selection. We'll use a typical valve for this case, such as the RCA C20T4. Two fields will then appear: the electrical on time and the remote pilot length. Let's put typical values for these two fields. For the electrical on time, we may use 100 milliseconds. Then the remote pilot length, we can use 1 meter, the recommended pilot line length. The next field to fill in is the header selection. Since we do not know the header volume, we need to solve for the header volume. Then the fields of header pressure and header temperature appear. We may use a typical value of 600 kilopascals for the header pressure, the initial header pressure. The header temperature can remain unchanged at 20 degrees Celsius. You will notice that the filter selection section has now appeared. As mentioned earlier, there are three options to choose from, three filters: the bag, cartridge and pleated filters. For the purpose of this instructional video, we need to choose a pleated bag filter. Then the pleated bag filter diameter input field appears. Any pleated bag filter inside diameter may be entered that is specified by the customer. It should be noted that this is the inside diameter of the pleated bag filter. The pleated bag filter consists of a cage making up the internal wall of the filter, followed with the pleated filter material placed around the outside of the cage. There are also plastic or otherwise mesh materials on the outside of the filter and retaining rings along the length of the filter that completes the filter assembly. A typical pleated bag filter diameter that is commonly used for a normal bag filter is that of, let's say, 150 millimeters. We can input that in this field. Please remember that if you're going from millimeters to inches or inches to millimeters, you will need to input the value, as this does not automatically change. For this example, we'll be using metric units. The next drop-down menu is to specify the pleated bag filter volumetric flow rate, or the filter area and needle cloth ratio. Incidentally, both of these parameters will result in the filter forward flow. This is a calculated field and not an input field. If we choose the filter area and needle cloth ratio, we should take note that the filter area is only for an individual filter. Another way to think of filter area is the filter area that is cleaned by an individual orifice from the blow tube. The parameter that needs to be determined also in this field is the air to cloth ratio. This is usually given by the customer. Now, if the customer specifies the total filter area, then the number of filters must be known to divide out the total filter area to calculate the area per filter that needs to be input in that field. If the second option is chosen, that of filter design flow rate, the volumetric flow rate and the individual filter volumetric flow rate, in particular that is specified by the customer, is input directly into this field with the appropriate units. If it so happens that the total volumetric flow rate is specified by the customer, then again, like the area, this must be divided out by the total number of filters to obtain, in this case, the volumetric flow rate per filter. When the values for either the filter area and air to cloth ratio, or directly, such as just discussed now, the volumetric flow rate, have been entered, the appropriate fields are then automatically calculated, that is, the filter forward flow at the bottom. Let's go through an example. If the filter area and air to cloth ratio is chosen, and we input a value of, let's say, 33 square meters for the filter area, and a typical value for the air to cloth ratio of 0.02 meters per second, you will notice that the filter forward flow has been automatically calculated. This is 660 liters per second. Again, different units may be chosen. If we select the filter design flow rate, then we input this value directly into this field. You will notice that the filter forward flow is again automatically calculated and identical to the design flow rate. The next field to be input in the filter conditions section is the pressure drop, this field here. The pressure drop is the difference in pressure between the incoming dirty or particulate laden air and the clean or filtered air passing out of the filter house or filter assembly. The pressure drop is identical between the inlet and outlet of the filter house and that from the dirty to the clean side of the filter bag. It is to be thought of as merely the pressure difference between these two extreme points in the filter process. The differential pressure is that pressure difference that results from the resistance to the flow by friction with boundaries and other flow obstructions, but mainly results from the pressure drop from the particulate buildup on the filter surface. A typical value that is used for this pleated bag filter case could be 1500 pascals. This completes the filter selection section to set up a pleated bag filter. There will be other filter cases such as using a venturi or possibly having two or more blow tube orifices pulsing into a single pleated bag filter. For these cases, it would be advisable to contact the GOCO8 engineering office. This completes this video in the series. As always, we hope you enjoy your GOCO user experience.